All right, this part of the lecture covers the details of mitosis. So however you want, in the corner, I'm going to write mitosis, which we know exists, but I've never told you about the details. I now wish I had, but that's okay, because I'm telling you now. Mitosis is a kind of asexual reproduction. Asexual cell reproduction. So we're going to use Fred's genome again. This should look familiar from the previous lecture. So he has 3 chromosomes from his mom, 3 chromosomes from his dad, for a total of 6 in all of his somatic cells. Just like before, goes through S phase. He's been in interphase. Goes through S phase, and now I have duplicated chromosomes attached to the centromere. And then they're back in interphase, so it's just waiting for mitosis. And what happens during mitosis is all of the chromosomes line up. So I'll draw my chromosome 1s. Oh, I hope they all fit. Chromosome 2. I'll put chromosome 3 up here, the little tiny one. And now you can see that if I cut these in half, I'll have 2 pieces of identical DNA. So basically, here's the cell starting to divide. You can color that in. There's the cell starting to divide. And essentially, it's like something came through here and pulled these 2 duplicated pieces of DNA apart. So if I were going to draw it again, it would look like this piece went this way. Just trying to not pick up my pens too many times. A little piece, big piece, little piece. So make sure you're drawing these in 2 colors. It'll make your life easier. And it becomes 2 cells. So actually what happens is that there's something that's pulling these apart. So something grabs each side and pulls them apart. So they get pulled apart from each other. And then we end up with 2 daughter cells. So let's see, I have 1, 2, 3 of those. Over here I have 1, a smaller and a smaller. Over here I can see I have 1 big one, a medium one, and a small one. A big one, a medium one, and a small one. Excuse the fact that my pictures are not perfect. Big one, medium, small. So compare these daughter cells to where we started. They look identical. We have 2 identical daughter cells that are identical to the parent. 2 daughter cells that are identical to the parent. Oh, sorry, to the parent cell. If we went through and labeled this as haploid or diploid, that's question number 1. Question number 2 is duplicated or unduplicated. I'm going to do that for each one of these boxes. I recommend that you pause. I'll pause in between, that you try to do it yourself and then check your answer. So for number 1, if I count up my chromosomes, actually let's remind ourselves that n equals 3. So 1n is 3, and that's haploid. 2N is going to be 6 chromosomes total, and that's considered diploid. So I'm looking at the first one. I'm going to see how many chromosomes I have. So 1, do I have 3 chromosomes or 6? I have 6, so it's diploid. And 2, is it duplicated or unduplicated? It's unduplicated. After it goes through S phase, I'm going to ask myself the same question. 1, how many chromosomes? So I can count up 1, 2, 3, 4, 5, 6. It's still diploid. I didn't get more chromosomes, but I did make copies that are stuck together at the centromere. So it's diploid, and it's duplicated. Right here in the middle of mitosis, still diploid. They're still duplicated. If I look right here, this one's a little more complicated because it's in between. For sure, it's still, I can count 1, 2, 3, 4, 5, 6 in this cell, and 1, 2, 3, 4, 5, 6 in this cell. We're considering that these are essentially 2 different cells already, so it's diploid. And we'll call it unduplicated. And lastly, so they used to be duplicated, and then we split them in half, and now they're still diploid, still 6 chromosomes, but they're unduplicated. And then I end up with diploid, unduplicated chromosomes. All right, pause here, go online and take the appropriate exit ticket, and then come back for the last video.